I'm Matt,
And I'm Gideon.
and we want to talk to you about something that's happening all over the world.
That's right. We're talking about momentum.
Momentum is the product of mass and the velocity of an object. My colleague Gideon will demonstrate some momentum.
Thanks, Matt. Here's a demonstration of velocity. As you see, I have this ball. As we go over here towards the floor, I'm going to roll this ball across the floor.
Look at that baby go.
As you can see, since the velocity of the ball was not increasing, its momentum was not increasing. If I were to increase the velocity on the ball, the momentum of the ball would therefore increase.
Now I get it. No, I don't. The equation for momentum, as most people know, is... That's right. It's P equals M times V, or momentum equals mass times velocity.
What about impulse?
Wow, I almost forgot. Impulse is the time in which the force is acting upon the product or object.
Oh, you mean like if I run into the wall because the momentum changes?
Precisely. Just don't forget that impulse equals force times times.
Gee, thanks, mister. Well, if we're going to be talking about momentum, you know we're going to be talking about some collisions. Boom.
Hey Gideon, I forgot a lot about collisions. Can you refresh my memory?
Certainly, old pal. When we talk about collisions, we talk about two types of collisions. The first is an elastic collision. This is when an object bounces off of something and no damage is done and no heat is generated.
Wouldn't another example be a football bouncing on the cement?
Yeah, that'd be a great example, Matt.
Let's do it. Hey, in this experiment, Gideon will be throwing this football at the ground. Notice
Matt.
which collision it is.
Pass me the rock.
Sure, dude.
Thanks, man. Alright, here's another example of an elastic collision. Exhibit A, the football, bouncing off of Exhibit B, the ground. Oh my god, no way!
What? Hey, Gideon, didn't you say there's two types of collision?
Yeah, there is, Matt. The second type of collision is an inelastic collision. This is where an object does not bounce off and breaks and heat is generated. Just like an egg getting crushed against the wall.
Sounds messy. Let's do it. Due to the messiness of this experiment, we will be doing it inside in a sink. Please do not do this at home.
This is an inelastic collision. This egg doesn't stand a chance against this sink. Let's watch what happens. Oh no! See? The egg is broken. And the way it broke is because heat was generated. Bye-bye.
Oh my. A lot of people ask themselves, what changes momentum? The thing that changes momentum is a change in velocity.
Hey Matt, I heard about this thing called the law of conservation of momentum. Do you know what it is?
Do I know what it is? Of course I know what it is. The law states that linear momentum does not change unless external forces act upon it. Duh.
Burst!
People ask, how is momentum conserved? Well, the answer to that is that if two objects hit each other, for example, one ball rolls into the other ball. When they hit, this ball may lose momentum, but this ball will gain that momentum. We will show you with real balls.
Hey Matt, I got the balls you wanted.
As you can see, the orangish reddish ball is stationary, while the ball in Gideon's hand will be providing the momentum. As the ball from Gideon's hand rolls into the orangish reddish ball, the momentum is transferred.